In this particular problem, we need to find out the value of this given expression. Here, omega represents the complex cube root of unity. So if omega is a complex cube root of unity, and we know that the cube roots of unity are 1 omega and omega squared, such that the product of the roots, which becomes omega cubed, that's equals to 1, and the sum of the roots, which is 1 plus omega squared, so that value is equals to 0. Now, let's try to find out the value of a given expression. So here we have a plus b omega plus c omega squared divided by c plus a omega plus b omega squared. This is added to a plus b omega plus c omega squared divided by b plus c omega plus a omega squared. Now we know that in order to add two fractions, the denominator must be the same, but in our case we have different denominators. What we'll do, we'll consider the second term. If we look at the denominator, we have b plus c omega plus a omega squared. We'll try to make it equal to the denominator on the first term. How do we do that? So here, let's look at the first term. Here, c has no coefficient. It's a coefficient of 1, but in our case, c has a coefficient of omega. But if we multiply omega squared to it, then c omega times omega squared, that will become c times omega cube, and we can use this fact. So that means c omega when multiplied to omega squared will become c. So in this case, what we'll do, we will multiply both the numerator and the denominator with omega squared. We'll simply do this multiplication. So let's do that. So this is going to give us, so we have a times omega squared. So that's a omega squared. Then b omega plus omega squared will become b omega cubed plus c times omega raised to the power of 4. Divided by, so here we have b times omega squared plus c times omega cubed plus a times omega raised to the power of 4. And we have the first term. Now we have a omega squared plus b omega cubed. B omega cubed will be simply b because omega cube value is equals to 1. So we have b plus we have c times omega raised to the power of 4. Now omega raised to the power of 4, that's also equivalent to omega cubed times omega, and omega cubed, that value is equals to 1. So this will be simply equals to omega. So we have c times omega divided by b omega squared plus c times omega cubed means c, since omega cubed is 1, plus a times, this is omega raised to the power 4, that this will be simply a omega. Now you can see that the denominator of both the two fractions are exactly the same, so that means we can add them up. Now we'll add up the numerator. So that means we have a plus a omega squared plus b omega plus c omega squared divided by the common denominator, which is a omega plus b omega squared plus c. Right. Now let's further simplify it. So we have a multiplied to 1 plus omega squared plus b multiplied to 1 plus omega plus c multiplied to omega plus omega squared divided by a omega plus b omega squared plus c. We will use the fact that the sum of the cube roots of unity, which is 1 plus omega squared, that value is equals to 0. So from here we can say that 1 plus omega will be equals to negative omega squared, or 1 plus omega squared will be equals to negative omega, or omega plus omega squared will be equals to negative 1. So we'll use these three values to rewrite our numerator. So we'll have a multiplied to 1 plus omega squared will be replaced with negative omega, plus b times 1 plus omega will be replaced with negative omega squared, plus c times omega plus omega squared, which will be replaced with negative 1, divided by a omega plus b omega squared plus c. That means in the numerator, now we have negative a omega minus b omega squared minus c divided by a omega plus b omega squared plus c. Now if we take negative as the common factor in the numerator, so we have negative times a omega plus b omega squared plus c, and the numerator and the denominator factors out to leave us with negative 1. So this is going to be the value of the given expression, provided omega is a complex cube root of unity. So this is negative 1.